Hello.
Hello, sir.
Yes. Hello.
Yes, sir. Can you hear me?
Yes, I can hear you. Can you get? Are you getting my voice? Okay. Hello. Just wait for a minute. I think there is some issue in the earphone. Okay. Speak something. Open your mic
Yes,
and
sir.
speak.
Are you there?
Okay. Just wait for a second.
Yes,
Can
sir.
you? Okay. Now speak again. Open your mic and speak something.
Yes, sir. Can you hear me?
Okay. Okay. Now you are audible to me. Am I audible to you?
Yes, sir.
Okay. Okay. So today have you joined with any new different Gmail ID?
Yes, sir. Like
Okay.
I joined with the yesterday's one.
Okay. I think is this your mom's Gmail ID? I think.
Gmail ID.
Today you have joined with different Gmail ID. Okay, it doesn't matter. Uh, okay,
Um,
okay. Now let me
I
tell
don't
you.
know.
Okay, now confirm me one thing that today are you unable to take the extra class like 2:30 to 4:30? You have sent me some message for the timing schedule.
Yes, yes, sir. Because my sister has class at that time, so that's why.
It means you have to go somewhere before after 4 p.m.
Yes, sir.
So it
I
means
have
you
math class.
maths class. Okay, fine. From 4 a.m.
Yes, sir.
Okay, it means today you will be able to join the class from 2:30 to 4, right?
Yes, sir. 2:30 to 4.
Okay, okay, no problem. Let me just open the PDFs and the required software.
Yes, sir.
So let's have the brief recap what we have studied yesterday. Yesterday we are to be starting that these matters around us pure, and we have discussed like the solution and the mixture and the homogeneous and heterogeneous and so on. Okay. So before
Yes, sir.
beginning to the new topic, let's have a brief recap, and I'll have these some questions to you. Okay, and you will explain this. One is a homogeneous type mixture, and the next is heterogeneous type of mixture. Can you distinguish between these two types in your own word?
Heterogeneous and homogeneous.
Yes.
Heterogeneous and homogeneous.
Homogeneous and heterogeneous, you have to make the distinction between these two.
Um. Okay, sir. Homogeneous. It has a uniform composition,
Uniform
and
composition of solid or the solid particle, whatever it makes dissolve in the solvent, okay, or in the
yes, sir.
mixture. And what is the
And
heterogeneous?
heterogeneous has non-uniform composition,
Non-uniform
like
composition means
like
non-uniform
mixtures.
distribution of particles. Okay,
Yes, sir.
fine. Okay. Now can you tell
Okay,
me
sir.
is there any fixed proportion for the mixture?
Oh, what, sir?
For mixture, is there any definite proportion of the constituent particles or the amount? Definite proportion for the mixture.
Um. Yes, there
For
is.
for mixture there is no. And when you are suppose making any compound, suppose any compound, for example, suppose we are taking the H2SO4, right? So it
Okay, sir.
follows the law of the definite proportion, like the definite proportion, like the two hydrogen atoms and one sulfur and four oxygen atoms. If you will increase the number of molecules, so the number of each and every atoms will increase proportionally. Okay.
Okay, sir.
Okay, tell me one more thing. What are the two examples of the solutions through which, when we allow to pass a light ray, so that means the path visible? What are the two examples of the solution? What two types of solution through which the path of light ray becomes
Suspension and
visible?
collide.
Suspension and
Colloidal.
colloidal solutions. Okay. Okay. Can you tell me on what factor does it depend and whether the light ray passing through any solution will be visible or not? I have told
Mm,
you yesterday. I I'm asking you, suppose if you have any solution, right? So
Okay, sir.
on what factor does it depend that whether the light ray passing through the solution will be visible or invisible?
Uh, like the particles,
Size of the particles, solid
the
particles, right?
size of the particles.
Okay, size of solid particles. Okay,
Okay, sir.
size of solid particles. And what are the two examples that you have told for the uh, making the light ray visible? One is suspension. Okay, one is
Suspension
one is
and
an example of suspension, and next is an example of colloidal solution. Okay.
okay, sir.
Okay, tell me one more thing. If we are dealing with the solution, so we have the two parts. One is called the solute, right? And the second is called
Yes,
the
sir.
solvent.
Solvent.
Okay, generally the quantity, right, the amount of solvent is greater than the amount of solute. Okay, in the similar way,
Okay.
if we have the colloidal solution, suppose we have colloidal solution. So for the colloidal solution, what are the two parts like solute and solvent? Dispersed phase and dispersing medium. Have you remember or not?
Yes, sir.
Dispersed phase and dispersing medium are the two constituents of the colloidal solution, right?
Yes, sir.
Can you explain some properties of the colloidal?
It is a
What it
heterogeneous mixture.
okay, whether it is a heterogeneous mixture, fine. I'm asking you that is there any special effect which occurs in colloidal solution only? What happens when a light rays pass through the colloidal solution?
Uh, and
Since its size is relatively
the
larger than the solid particles of the suspension, so what
so it will be visible.
okay, I know that it is visible. I'm asking you, is there any other effect in the colloidal solution? Yesterday we have discussed about it.
They do not settle down.
Yes.
They do not settle down when they are undisturbed.
Okay, when it is left undisturbed for some time, then it is not settled down. It means precipitate is not formed. Okay, but I'm asking you that is there any special effect in the colloidal?
They cannot be separated by the process filtration.
You are not getting what I'm asking you. I'm not asking you the property of the colloidal solution. I'm simply asking you that is there any other effect apart from the making the path of the light ray visible in the colloidal solution? You have forgot, I think.
And Tyndall effect.
Tyndall effect, yes. This is the thing for I was waiting, right? Tyndall effect. What is the Tyndall effect? Explain in your own word.
It is a scattering of beam of light.
Scattering of beam of light. Like when a light is allowed to pass through the colloidal solution, then when it is scattered with the solid particle, then like when it collides with the solid particle, then it is scattered in the different directions. And this effect is called the Tyndall effect. Okay.
Okay,
This
sir.
effect of light is called the Tyndall effect, and I have also told you to underline that point, like Tyndall effect.
Yes, sir.
Okay. Now let us move to the next. Did I share the screen or not? I think I
No, sir, you
haven't shared
didn't.
the screen, huh? Isn't it?
Yes, sir, you didn't, sir.
You should
Yes, sir.
have remembered me. Huh? It's when I forget to share, so it's your responsibility to remember me. It might possible that I forgot to share the screen. I had told you earlier. Okay, anyway. Now is it okay?
Yes, sir.
Okay. This much of thing we have explained, and screen is still not shared. Is it something strange? Anyway, now let's continue. Just wait. Is matter around a sphere, I think, na? Right?
Yes, sir.
Okay. I think we will be beginning with the elements and compound and distinction and difference between the elements and compounds, right?
Yes, sir.
Hello?
Yes, sir.
Okay. His PDF is visible on your screen?
Yes, sir.
Okay. So from where we have to start? I think from
Elements.
elements and compound, right?
Yes, sir. Element.
Okay, fine. Okay, tell me one thing, the maths class which you study, you took the online or the offline?
Math, so I go for offline.
Okay, okay, it's okay. So you have to go for the distance apart. Is there a large distance to go, or just in joining your residence?
So it's fine. It's walkable distance. I can reach like in 10 minutes.
Walking distance. Okay.
Yes,
Okay,
sir.
fine. Now let's see here from elements. As we have already told you that the element is what? Element is actually the extremely pure substance. The basic difference between the elements and compound, that element is an extremely pure substance. Okay, it is extremely pure
Okay.
substance, and when you try to break it into more simpler forms, you cannot break it into more simpler form. One thing. And the next property of the element is what? The all the constituent particles, whether atoms or ions, which forms the element, will have the same characteristic, right? For example, suppose if
Yes.
we are considering any element, suppose sodium, so all the sodium atoms will show the same characteristic. It doesn't mean that one sodium atom will show the different and other will show the different characteristic. All the elements, all the atoms or the constituent particles of the elements will show the same characteristic, like atomic number, mass, chemical properties, valency, etc., and all that. Okay.
Okay, sir.
So element cannot be broken into more simpler substances. The first thing is okay.
Okay, sir.
And when two or more elements, when two or okay, can you first of all can you give me the some examples of elements? Give me some examples of element.
Gold, silver,
Gold. Why it is first come to your mind? Why gold? What is the atomic number of 30? What is the atomic number of gold? Do you know?
and no, sir.
Okay. So how is that? How sudden gold has come to your mind? Only gold. Is there are many elements before gold, like hydrogen, sodium, potassium, helium, lithium, beryllium, and so on. Anyway, tell me more components, more elements. Example.
Oxygen, hydrogen,
Oh
helium.
yes. Okay. Helium. Is there any something
Yes.
special with the helium element? Do you know? I'm asking you, is there something
Um,
special with the helium element?
helium.
What is
They
the
are non-metals.
okay? What is the atomic number of helium?
One.
One. Helium has one atomic number.
Helium. No, no, no. It is two.
Two, right? How can you
Yes, sir.
forget such a small thing? Helium has a two atomic number. It is very light gas. Okay.
Okay, sir.
Okay. And tell me more examples of elements. Next example is sodium. Suppose
Oxygen,
sodium. What is
helium.
the atomic number of sodium? 11, right?
Four. Yes, sir.
11.
11.
Can you tell me the valency of sodium? I had already discussed this in the previous chapters. Sodium has
So,
1 plus charge because it has tendency to, if any element, there is a lot of noise from your side.
yes, sir.
Okay, this is sodium atom and its valency is plus 1, right?
Two.
Its valency is plus 1.
Yes,
This
sir.
shows that it has tendency to donate either one electron or gain one gain to donate or gain one electron. Which one is right? It will donate the electron or it will accept the electron from other. Now remember one thing, if there is plus charge, okay,
Accept.
if there is plus charge on any element, this shows its tendencing capacity, no sorry, its donating capacity, right? It has tendency to donate the electron. Okay, it has tendency to donate electrons, and if there is negative charge, it means it has tendency to accept electrons. Okay, this is why these types of atoms called the donor atoms, while the elements which has tendency to accept electron called the acceptor atoms. Okay,
Okay, sir.
can you give me some example for the acceptor atoms when there is a negative charge? Give me some example of the
Uh, Chloride.
fluoride, right? It has
Chloride.
tendency to accept one electron,
Yes, sir.
and chloride also.
Yes.
This is fluoride, this is chloride, and there is one more special thing I'm telling you. Listen, fluoride, chloride, and Br minus, this is bromide, and I minus, this is iodide. Okay, why we have listed these
Okay.
four elements together? Because it has some important thing. These all four elements are called the halogens. What are they called? Halogens. Okay,
Okay.
these four are also called as halogens, so remember this. Anyway, okay, so
Okay, sir.
we will be telling you that when two or more elements, right, when two or more elements combined, okay,
Okay, sir.
combined together in definite proportion. Definite proportion, this means this proportion may be by number of atoms, or maybe by definite proportion by mass, or definite proportion by number, because both of these rules are hold. Okay, definite proportion by mass and definite proportion by number. So are you getting these two things in a exact way what I'm trying to say you, or not?
Yes, sir.
Let's take one example. Suppose, for example, one of the simplest example, suppose I have taken the H2O molecule, right, one hydrogen molecule. So if you look for the definite proportion by number, okay, if we see the definite
Okay, sir.
proportion by number, so we will see that if we list the number of hydrogen and oxygen atom in one molecule of water, so obviously there are two hydrogen atom and one oxygen atom, right? It means hydrogen to oxygen ratio will be 2:1. This is by number. Okay, it means if you
Okay, sir.
increase the number of molecules, so hydrogen numbers and oxygen atoms will increase in a same proportion. And the second one is, if we look for the definite proportion by mass. Okay, are you listening to me?
Yes, sir.
Okay, just focus on your screen. Okay, don't divert your mind. By mass, if we
Yes.
come to the definite proportion by mass, so what is the atomic mass of hydrogen? 1, obviously.
One. Yes, sir.
And oxygen, atomic mass of oxygen, its atomic number is 8, then its atomic mass will
8.
be, atomic mass of the oxygen will be 16.
16. Yes, sir.
So if we see the ratio hydrogen to the oxygen by mass, so is it going to be 1 into 16, 1 is to 16, isn't it?
Yes, sir.
Okay, this will be 1 is to 16. So these are the two ways to represent the definite proportion rule. Okay, so now
Yes.
you got it.
Yes, sir.
Okay, so when two or more elements combine together in definite definite proportion, right?
Yes, sir.
The two laws that I have told you right now is also termed as the law of chemical combinations, basic law of the chemical combination, like the law of definite proportion by mass by number. Okay, so when two or
Okay,
more
sir.
elements combine together in a definite proportion, the then compound is formed. Okay, so compound is
Okay, sir.
actually what? Compound is the combination of the two or more elements in a definite proportion, right?
Yes,
For
sir.
example, like HCl molecule, this is example of compound, right? H2SO4, hydrogen sulfuric acid, hydrogen sulfate, or in other words, this is also called the sulfuric acid, and HNO3, These are acids. Can you name this compound which I have written just? HNO3. What is its name? Tell me. Respond something and I'm waiting for you.
HNO3 is
Hello? Are you
hydrogen
listening to me?
nitrate. Yes, sir.
Hello?
Hydrogen nitrate.
Just a
Hello, sir. Can you
second. I
hear
think
me?
there is.
Sir, can you hear me?
Just a second. Okay, try to say once again. Okay,
Sir,
okay,
can you
okay.
hear me?
Okay, okay. Now it is okay. Okay, so I was asking to you that can you name this compound? Last one.
Hydrogen nitrate.
Not hydrogen nitride. I'm asking for the common name of this compound. In the scientific, we can also say the hydrochloric acid and the hydrogen sulfate. But what is the common name of this compound? I'm asking you. Don't you know?
Mm,
Okay, let's say I'm telling you. Okay, this is called the nitric
okay.
acid. Which type of acid?
Nitric acid.
Okay, is it okay?
Okay, sir.
This is called nitric acid. Okay, now let's move further. Okay, elements. So these are the some characteristics of the elements. Now start reading from here and I will make you explain wherever it is necessary. Start reading this para.
Okay, sir. Elements can be normally divided into metals, non-metals, and metalloids. Metals usually show some or all of the following properties. They have luster, shine. They have silvery green, gray, or golden yellow color. They conduct heat and electricity. They are ductile, can be drawn into wires. They
Okay,
are malleable, can be hammered into thin sheets.
okay.
They are sonorous, make a ringing round
What
sound
property is called
when
the sonorous? Sonorous means when you hit any element with the help of any other element, so that will produce a sound. This property is called the sonorous property. And the malleable, what is malleable means when you have this some element, so when you hammer this, so you can convert this into form of sheet. This property is called the malleable property, right? The next one is ductile. Ductile property is ductility. Is also called the ductility of the metal. It means you can drawn into the in the form of wires. Okay.
okay, sir.
Okay, along with this point, let's have the one more the important information about the ductility. Can you tell me that which element, which metal has the highest ductility?
Gold.
Which? Yes, gold has the highest ductility. Can you tell me what is the what amount of what length of wire can you draw in a 1 gram of gold? Think and tell me. Okay, take your time.
Okay, so 1 gram of gold.
Okay, think it and then tell you. Don't make fast. Okay.
Mm, two, two, two,
Actually, when you have the 1 gram of
two.
gold, so it is approximately can be drawn into approximately 3 kilometer length. Now you can think that how large ductility gold has. Okay.
Okay, okay, sir.
Okay.
2 kilometer. Okay.
Now the next is they have the silver, gray, golden, yellow color. Okay. They have the luster. Luster is it means shine. It means it will reflect the
Fine.
light when it will incident on a surface. Now there are some examples of the metals are written here like gold, silver, copper, sodium, potassium, etc. Now this is the important point. Now underline this point which I have selected and read this.
Yes, sir.
Underline and
Mercury is the only metal that is liquid at room temperature.
okay, all the metals are generally found in the solid state, right? Mercury is the
Yes,
only
sir.
metal. Mercury is the only metal which is found at in liquid state at room temperature. Okay.
Hmm. Yes, sir.
Mercury is the only metal which is found in the liquid state.
Okay, sir.
Now there are some non-metals. Examples of the some non-metals. Now start reading this point. These points. Properties of non-metals.
They display a variety of colors. They are poor conductors of heat and electricity. They are not lustrous, sonorous, or malleable.
Okay.
Examples of nonmetals are hydrogen, oxygen, iodine,
Iodine.
carbon, coke,
Okay. Bromine, chlorine, etc.
chlorine, etc.
Okay.
Some elements have intermediate properties between those of metals and nonmetals. They
Non-metals,
are
right?
called metalloids.
These
Examples
elements
are
are called the
boron,
metalloids, which will show the properties of the metals and non-metal both. Example are like boron, silicon, and germanium.
boron, silicon,
Okay.
germanium.
So if we
Okay,
look
sir.
for the metalloids, what are the example? Boron, silicon, and
Boron,
germanium.
silicon,
Okay.
germanium.
Okay. There is
Okay,
one
sir.
more. There is one more important thing to be discussed with the last two elements, like with silicon and germanium. Okay. Do you have
Okay,
any
sir.
other information for these two elements, silicon and germanium? What are they else called? They are also called the semiconductors. What?
Semiconductors.
These elements are also called as semiconductor. In fact, these are the semiconductors, right?
Yes, sir.
Okay, now move to the next point. Okay, there are some points which are written here. The first is the number of elements known present at more than 192 elements are naturally occurring, and the rest are man-made. Okay, the majority of elements are solid. This means the maximum number of elements which are found in the solid state. Okay, and there are only 11 elements which are found in the gaseous state at the room temperature. Okay, now many times this word has come, that the room temperature. What does the room temperature actually mean? Tell me. What does it mean by the
It's
when we say the room temperature, then what does it mean?
room temperature is the normal temperature right now.
Okay, there will be some amount, some fixed quantity, some numeric value. What is that in the degree Celsius? What is the room temperature in degree Celsius?
Room temperature in degrees Celsius.
Do you know or
Um,
not?
20, 20.
25 degrees Celsius. Now remember these points. Okay, 25 degrees
Oh,
Celsius.
yes.
25 degrees Celsius is called the room temperature, right? So whenever this word come room temperature, so automatically you should know that this temperature is 25 degrees Celsius. Okay.
Okay, sir. Okay, sir.
Okay, now the next point is the two elements are liquid at room temperature, like mercury and the bromine. And the bromine is the like mercury and bromine, these are the two only elements which are found in the liquid state. Okay,
Okay.
there are also some
Okay, sir.
elements like gallium and cesium become liquid at room temperature, like 303 Kelvin. Which are those? Gallium. Which one?
Gallium. Gallium and
Cesium. Cesium.
cesium.
Gallium is color is gallium has silver
Silver.
color, and its melting point is very low. That means at room temperature you can find this in the liquid state.
Yes,
and
sir.
and even when you put gallium on your palm, when you put
It will
gallium
melt.
on your palm and then it will melt. Okay.
Yes, sir.
Okay, now can you tell me one more element which can be cut with the help of knife? Metal which can be cut with the help of knife.
Sodium.
Sodium. Right answer. Sodium is the only element which can be cut with the help of knife. Okay, like
Okay,
soap,
sir.
like cutting of soap. Okay, now the next point is compound. So we have already discussed the some basic points of the compound, but read from this point. A compound is what?
Okay, sir. A compound is a substance composed of two or more elements chemically combined with one another in a fixed proportion.
Yes. Now you have to underline this word, fixed proportion. This word has very great significance for the compound. When you not mention this word, then your definition will not be correct. Remember this thing. Underline the fixed proportion that I have already told you, isn't it?
Yes, sir.
Have you marked the fixed proportion?
Yes, sir.
Okay, fine. Now let's move further. Now, mixture and compounds. Now, mixture and compound. I have already told you that what is the basic difference between mixture and compound. Tell me once again. If you have remembered that in the yesterday class, the first thing that I had told you, the basic difference between the mixture and compound. Suppose you have the 2 or 3 ingredients like ABC, and when you mix all these three without any definite proportion, so you are going to get mixture, right? But when you are
Yes, sir.
mixing these 3 ingredients in some fixed amount, like in the some fixed definite proportion, then you will get compound. So this is the basic difference
Compound.
between the mixture and compound. Did you get this?
Yes, sir.
Okay, now there are some points written for the comparison between the mixture and compound. Now start reading. First point is
Mixtures.
okay, mixture.
Mixture. Elements or compounds just mix together to form a mixture, and no new compound is
Oh,
formed.
it means when you mix the two elements, so you are not going to get any new compound. No new substances will be found. Whereas in case of compounds, elements react to form new compounds, right? It means there is no chemical
Yes.
reaction for the formation of the mixture, where there is a chemical reaction occurs for the formation of compound, right?
Okay.
Chemical
Okay, sir.
formation of
Yes.
a compound, there is a chemical reaction occurs. What is the second point?
A mixture has a variable
Variable
composition
composition.
compound.
The composition of the new substances is always fixed. This is the basic difference between the mixture and the compound, which you have to remember. Mixture has no definite proportion, right? It has no definite proportion, no definite quantity.
Yes.
It has variable composition, whereas in case of compound, the compound of each new substance is always fixed. Okay. Now
Okay.
third point.
A mixture shows the properties of the constituent substance, the
Yes,
new substance that totally
from properties.
different properties.
It means when you are forming the mixture, so mixture will show the properties of the constituent particles or the constituent substance, whereas when you form the compound, then compound will show the totally different properties apart from the constituent particles which you have mixed into.
Okay, sir.
Read the fourth one.
The constituents can be separated fairly easily by physical methods.
Yes.
The constant can be separated only by chemical or electrochemical reactions.
Electrochemical reactions. Okay, it means if you have the compound, so you cannot easily separate its constituent particles, whereas in case of mixture you can easily separate the constituent particle by the physical method. Okay.
Okay, sir. Okay, sir.
Now the next. Now come to the next. Now this is a very important flow chart that is visible on your screen, right?
Yes, sir.
Now see here, this diagram shows how can we classify the matter, right?
Yes, sir.
Now look at just a minute. It has come. Okay. So matter basically, broadly, you can classify the matter in the two way. First is the pure substance, and the second is what mixture. And it is written that the no fixed composition. This is the main point for the mixture. The mixture can further classify in the two parts, which one is homogeneous and heterogeneous. The basic difference for homogeneous is what? Homogeneous composition, whereas for heterogeneous there is non-uniform composition, right?
Yes, sir.
And the examples of homogeneous like the sugar in water, salt in water, these are the examples of homogeneous mixture, whereas the example of the heterogeneous mixture like the sand, salt, sugar and salt, etc. Now when we come to the pure substances, so it can be classified in two parts. One is elements, next is compound. Element is what? Element cannot be broken down to the simpler substances. It means it is the simplest unit of the substance. and compound have the fixed composition, can be broken down by the chemical or the electrochemical reaction, right? With the help of the electrochemical reaction, you can break this into the simpler constituents particles. Examples of the elements are like copper, oxygen, etc., and the examples of compound like water, methane, sugar, etc. Do you know what is methane? Have you listened about the methane? What is its chemical formula? Methane. Do you know
Um,
what is methane? Actually, this is organic compound like
yes, sir. It's used to make
no, no, no.
heat and light.
Methane. Its chemical formula is CH. Its chemical formula is CH4. Okay.
Okay, sir.
Do you know what is the chemical formula of the salt? Salt that is used in our kitchen. What is the chemical formula of salt?
NaCl.
NaCl, right? Sodium chloride. Okay.
Okay, sir.
Now there are some important points which you have to read, and I will make you explain wherever it is necessary.
Yes, sir.
Okay, now start reading the points.
A mixture contains more than one substance, element, and or a compound mixed in any proportion.
Okay.
Mixtures can be separated into pure substance using appropriate separation techniques.
Yes.
A solution is a homogeneous mixture of two or more substances. The major component of a solution is called the solvent and the minor the solute.
Okay.
The concentration of a solution is the amount of solute present per unit volume or per unit mass of the solution.
Okay. Next point.
Materials that are insoluble in a solvent and have particles that are visible to naked eyes form a suspension. A suspension is a heterogeneous mixture.
Okay, mark this point. That the suspension is a heterogeneous. Mark this line. Suspension is a heterogeneous mixture. Okay, you have to make remember this point.
Okay, sir. Colloids are heterogeneous
Colloids.
mixtures in which the particle
Size.
size is too small to be seen with the naked eye, but it is big enough to scatter light. Colloids are useful in industry and daily life.
This means that the particles of the collide, whether its size is very small, but it is sufficient enough to scatter light, which causes the Tyndall effect. Okay.
Okay, sir.
Now
Okay, sir.
read from this. Collides are
The
useful.
colloids are useful in industry and daily life. The particles are called the dispersed phase, and the medium in which they are distributed is called the dispersion medium.
Dispersion medium. So these two are the important constituents for the collides. Underline this. One is dispersed phase and another is dispersion medium. Have you
Okay, sir.
underlined this?
Yes, sir.
Okay, the next point is pure substance.
Pure substance can be elements or compounds. An element is a form of matter that cannot be broken down by chemical reactions into simpler substances. A compound is a substance composed of two or more different types of elements, chemically combined in a fixed proportion.
Have you read this point?
Yes, sir.
Read this again.
Pure substances can be elements or compounds. An element is a form of matter that cannot be broken down by chemical reactions into simpler substances. A compound is a substance composed of two or more different types of elements, chemically combined in a fixed proportion.
Okay, fine. Now move to the next point.
Properties of a compound are different from its constituent elements, whereas a mixture shows the properties of its constituting elements or compound.
This is the basic definition, basic difference between the mixture and compound, right? You have to know, mark it, underline.
Okay, sir.
Okay, that means the properties of the mixture. When you have the mixture, so mixture will show the properties of its constituents, Okay, whereas the compound will show the totally different properties from its constituents. Okay,
Okay. Okay, sir.
underline this point. This para is important. Underline this. Have you marked it?
Yes, sir. Yes, I marked.
Okay, now there are some
Yes, sir, I marked it.
okay, there are some questions and exercise you can practice at your home. If you find difficulties, you may ask for. And now we are moving to the next chapter, which is I think matter sounds.
Atoms and molecules is the next chapter.
No, no, no. Atoms and molecules we have already discussed. Have you forgot that?
Yeah. Yes,
Atoms
sir,
and
but
molecules we have already discussed. The only one chapter remained in the chemistry, that is the structure of atom and matter in our surrounding. And after completing this, we will again come back to the topics that contains the numericals and derivations like motion, laws of motion, momentum, linear momentum, sounds, etc. Right?
yes, sir.
Anyway, now we are moving to the next, that is the matter in our surrounding.
Okay, sir.
Okay, just wait for a moment. Now this is written as the physical nature of the matter. तो बाहर जाना दरवाजा बंद कर देना, किसी बंदा रहेगा बोल नहीं. Okay, hello.
Yes, sir.
Just start reading this para. Physical nature of matter. Okay.
Okay, sir. Matter made up of particles.
So first thing is that
For a long
matter
time.
is made up of particles. Okay.
Okay, sir. For a long time, two schools of thought prevailed regarding the nature of matter. One school believed matter to be continuous like a block of wood, whereas the other thought that matter was made up of particles like sand. Let us perform an activity to decide about the nature of matter. Is it continuous or particulate?
Okay. This is the property of the matter. And one thing that any substances is made up of particles. Okay. So listen
Okay, sir.
what I am telling you, and then you will read. Okay. So as
Okay,
we
sir.
know that the matter, all the matters are made up of particles. So there should be some definite rule or pattern that how they are composed, how they are structured, where they are located, what is the separation between the constituent particles. So on the basis of the separation, and what is the separation between the constituent particles, this is called the intermolecular distance. Okay, the distance between the constituent
Okay.
particles of matter is called the intermolecular distance, on the basis of which we can classify the matter in the three states like the solid, liquid and gaseous state. We will come to
Yes.
this point later on. First of all, see here, suppose we have considered any substance here, and suppose I am just locating its constituent particles with the help of this red dot. Okay, suppose this
Yes, sir.
like this. So actually there is some definite structure for the particles that they are located.
Okay, sir.
And the distance between these two constituent particles is called the intermolecular distance. What is it called?
Intermolecular distance.
This is called the intermolecular distance, and which may differ to the different states, and on the basis of this distance we can classify the substances into the three states, basically solid, liquid and gaseous state. If we discuss for the solid,
Okay.
if we discuss for the solid state, if we discuss for the solid state, so in case of solid, these constituent particles are closely packed. Okay, particles or the
Okay, sir.
molecules are closely packed. Molecules are very closely and tightly packed. Okay, it means
Okay.
in case of solid there is no intermolecular distance, or there is very least intermolecular distance between the constituent particles or the molecules. Whereas in case of liquid, whereas in case of liquid there is sufficient intermolecular separation between the molecules so that they can like flow with each other, float in. Okay,
Fluidity.
yes, that property uh, results to the fluidity, like the fluid has the property to the flow, property of
Yes, sir.
flowing. The next is gaseous state. Which state? Gases. In the gaseous state,
Yes.
the constituent molecules or the particles are very far away, like this, and they always keep on moving, they never come to rest. Although in case of liquid also the particles move on, but in case of gas the particles move with considerable velocity and possess the kinetic energy. And suppose when gas is filled into any container, so the constituent particles will collide with the wall of the container, and hence it will exert the pressure over the wall, right?
Yes, sir.
For example, suppose if you have any balloon and air suppose is filled into this balloon, so the particles of the air will exert the force on the wall of the balloon, which causes to blow the balloon, which increases the size of balloon, right?
The balloon. Yes, sir.
Okay. Now it is written how small are these particles or matter. We will come to this. Okay, just a second. I think there is some issue in the software. It is not working. Okay, it starts working. Okay, fine.
Yeah.
Okay, so the particles are very small. Okay, it is obvious particles are very small and we cannot see by the naked eyes. Now there is characteristics of the particle. This is important. Now characteristic of particles we will see.
Yes, sir.
Now characteristics of particles. Now I start reading this para.
Yes, sir. Characteristics of particles of matter. Particles of matter have space between them. In activities 1.1 and 1.2, we saw that particles of sugar, salt, Dettol, or potassium permanganate got evenly distributed in water. Similarly, when we make tea, coffee, or lemonade, nimbu pani, particles of one type of matter get into spaces between particles of the other. This shows that there is enough space between particles of matter.
Of the matter, and this is the space for which we were just telling you that distance is called the intermolecular distance, right? Recently I had told you.
Yes, sir.
Okay, this is about these things that I had told you.
Yes, sir. Particles of matter are constantly moving.
Moving, yes, and this motion is called the Brownian motion, that will come later on.
Okay, sir. Particles of matter are continuously moving, that is, they possess what we call the kinetic energy. As the temperature rises, particles move faster. So we can say that with increase in temperature, the kinetic energy of the particles also increases. In the above three activities, we observe that particles of matter intermix on their own with each other. They do not so by getting into the spaces between the particles. This intermixing of particles of two different types of matter on their own is called diffusion.
Okay, read the next
we
line.
can observe.
Repeat the last line.
Okay, so this intermixing of particles of two different types of matter on their own is called diffusion.
Okay, underline this. This is very important line. Okay, the
Yes, sir.
intermixing of the particles of the two different types of the matter in their own is called the diffusion. This process is called diffusion process. Okay,
Okay, sir.
underline this.
Yes, sir, I underline.
Okay, so diffusion, if someone asks you what is the diffusion, so you will say actually diffusion is what? Diffusion is
Intermix.
intermixing of the particles of the two different types. Suppose when you have one, suppose this is one blank container you have, or the empty container you have. Okay, or suppose it contains some liquid. Okay, suppose it contains liquid A, and when you pour another liquid, suppose B, from any next container, okay, it also contains some.
Okay, sir.
Okay, this container also contains some another liquid. So when you mix with this, so the molecules of A and B will start moving towards each other, and they will mix up with each other. So this process will called as diffusion process. So diffusion is actually, it is intermixing of the particles. Okay,
Okay, sir.
particles of okay, this is written, the particles of matter attract each other. This force is called the intermolecular force. Okay, the force acting between the
Okay,
two molecules, the force acting between the two molecules that I have told here, this force is called the intermolecular force. This force is called what? Intermolecular force.
okay, sir.
Okay, so such a force which acts between the two molecules is called the intermolecular force. And so we can say that in case, can you tell me that in what cases like solid, liquid and gas, in which one of these intermolecular force is greatest?
In solid,
Obviously, in case of solid, the intermolecular force is high enough to bind the molecules together, whereas in case of liquid, they are loosely bound. Okay, it means there is a weak intermolecular force, and for the case of the gas, intermolecular force is very least, and hence they do not attract each other, rather than they keep on moving in the fixed some container or the volume.
yes, sir.
Okay, now we are just moving to the next. Okay, there is a states of matter. So this point I have already make you explain that the solid, liquid and gas, there are also some other states of the matter, like okay, solid, liquid and gas, there is
Bose-Einstein.
Bose-Einstein condensate, and like gases, vapors, these are the actually the different forms of gases. Now start reading the states of matter.
States of matter. Observe different types of matter around you. What are its different states? We can see that matter around us exists in three different states: solid, liquid, and gas. Three states of matter arise due to the variation in the characteristics of particles of matter. Now let us study about the properties of these three states of matter in detail. The solid state. All of the above are examples of solid. We can observe that all of these have a definite shape, distant boundaries, and fixed volumes.
Okay,
That is, have
wait. Now listen. When we come to the solid, so solid, liquid, and gases, all these three states will have or will possess some definite characteristic. Like the solid will have the definite shape. Okay,
okay, sir.
solid will have definite shape, whereas the liquid will not possess the definite shape. It will take the shape of the container in which it is filled. Okay, and the similarly for gas
Okay, sir.
also. And when we talk about the volume, then the volume of the solid is fixed, volume of solid is fixed, and the volume of liquid is also fixed, and the volume of gas is not fixed, because it will take the whole part of the area in which container it is kept. Okay, These are the some basic
Okay,
properties of
sir.
the solid, liquid, and gaseous state. Now start reading. Where were you?
Okay, sir. All of the above are the examples of solid. We can observe that all these three have a definite shape, distinct boundaries, and fixed volumes, that is, have negligible compressibility. Solids have a tendency to maintain their shape when
Now there is
subjected
one more
to
another
outside
word.
force.
Now there is one more another word comes. Now listen, compressibility. What is the compressibility? Compressibility
Compressibility
is
means
means actually in other way we can say it is the process of reducing the volume of any substance is called the compressibility, right? Suppose if you have any solid substance like this wooden block, or suppose one of the wooden or the iron block, so obviously you cannot shrink it. That means you cannot reduce its volume by
no.
applying the force on its edges, right? This means the
Yes, sir.
solid has no compressibility, whereas in case of liquid has compressibility. That is, the liquid can be compressed, whereas gases have higher compressibility than the liquid
Highly
state.
compressed.
Okay, okay. When you apply the high amount of force over the gas, so actually this gas can be converted into the liquid state as well, and this process is called the liquefaction, which we will discuss later on. So the main thing is that the compressibility is actually the process of reducing the volume of the any substance on applying the force on its edges. Okay, so this means the solid does not have the
Mm.
compressibility where liquid has, and the gases has also compressibility, which is in the greater amount than the liquid state.
Okay, sir.
Compressibility. Okay, now read from here. Solid have tendency to maintain their.
Solids have tendency to maintain their shape when subjected to outside force. Solids may break under force, but it is difficult to change their shape, so they are rigid.
Yes.
Consider the following. What about a rubber band? Can it change its shape on stretching? Is it a solid? What about a sugar and salt? When it's kept in different jars, these take the shape of the jar. Are they solid? What about a sponge? Is it a solid? Yet we are able to compress it. Why?
Okay.
All the above are solids,
Just wait.
as
Just wait.
a rubber band is
Wait. Just let me check that what points are important for the exam point of view. Okay. Now we come to the next state called the liquid state. Okay. So we have the main points of the liquid. I have already told you. The only thing is to just read the some points which I'll tell you. Wait. Okay. You start reading this much of whichever I have selected. This is for the liquid state, and that I have already told you, as there is a weak intermolecular force acting between the molecules in case of liquid, so
yes.
the particles are not tightly bounded, so they can freely move from one point to other point, right? That means in case of the liquid
Yes.
state like water molecules keeps on moving, it does not come to rest. Okay.
Hmm.
Okay, read this
Okay,
para,
sir.
read the para which I have selected.
This is due to the fact that in liquid state, particles move freely and have greater space between each other as
Yes,
compared to particles in the solid
solid
state.
state, right? So this is the basic difference between the liquid state. Now we'll come to the gaseous state. You don't have to read this much of activity. Just come to the point. What I will tell you. Just wait for a moment.
Gases are highly compressible.
Yes, the first point is that the gases will be highly compressible, which I had already told you. Now we have observed. Okay, now if we start reading from here.
We have observed that gases are highly compressible as compared to solids and liquids.
Okay.
The liquid The
Petroleum.
liquefied petroleum gas LPG
LPG.
cylinder that we get in a home for cooking
Yeah.
or the oxygen supplied to hospitals in cylinder is compressed gas.
Yes, that is a compressed gas. It means that is not generally found in the liquid state. That is compressed and filled into the cylindrical tank. So that comes to the state of the liquid. Okay, so LPG, if someone asks you full form of LPG, so you have to learn this: liquefied petroleum gas. Underline this: liquefied petroleum gas.
Okay, sir.
Okay, now read further.
Compressed natural gas (CNG) is used as fuel these days in vehicles. Due to its highly compressibility, large volumes of gas can be compressed into a smaller cylinder and transported easily. We come to know of what is being cooked in the kitchen without even entering there, by the smell that reaches our nostrils. How does the smell reach us? The
Yes,
particles of the aroma of the food mixed with the
CNG is
particles
called the
of air
compressed natural
spread from
gas.
the kitchen reach us and even farther away.
Just underline this much of part.
The smell of hot cooked food reaches us in seconds. Compare this with the rate of diffusions of solid and liquids.
Okay, are you
Due
not
to the
getting my
high speed
voice?
of particles of large space between them, gases show the property of diffusion very fast into other gases.
Okay, fine. Now, are you not listening to me? Are you not getting my voice?
In gaseous state, the
Am I audible
particles
to you?
move about randomly at high speed. Due to this
There is some network
random
issue
movement,
from your side. Are you audible?
particles hit each other and also the walls of the container. The pressure exerted by the on the walls of the container.
Okay, fine. Now listen to me. Am I audible to you? Hello?
Sir, I can't hear you.
I'm speaking. Am I not audible to you? Am I audible to you?
Sir, I can't hear you.
Just wait.
So you're speaking,
Yes,
but
I'm speaking. There is some
I can't hear
there is,
you.
there is some network issue from your side, I think. I was continuously speaking since last 1 minute, 1 or 2 minutes. I was not getting any response from your side. Just wait, okay? Just wait for a moment. Let me check out what issue comes.
Hello, sir.
Okay, am I audible to you? Am I audible to you?
So, yes, so now you're audible.
Okay, now are you
Yes,
getting my
I couldn't hear
voice?
you before.
Currently, am I audible to you?
Yes, sir.
Okay, fine. Actually, I was continuously
Yes, sir.
speaking for last 2-3 minutes, and I was not getting any response from you. That's why I had told you. Okay, now come to here. The thing that I have selected, underline this: CNG, compressed natural gas. Underline this. Are you listening to me? Hello? Hello? Is there some issue occurred?
Yes,
I
I'm
think?
listening.
Okay, okay. Am I audible to you?
Hello, sir.
Yes, am I
Can you
audible?
hear me?
Yes, I can hear you. I'm asking you, am I audible to you or not?
Yes, sir, you are audible.
Okay, okay.
Yes, sir, you are audible.
Okay, okay, fine. Now underline this compressed natural gas that I have selected on the screen. Underline this. Have you underlined this?
Yes, sir, underlined.
Okay, okay. Now come to here.
Yes, sir.
Diffusion of solid and liquid due to the high speed of the particle and large space between them. The gases show the properties of diffusing very fast into other gases. Okay. Now listen to me. Are you listening to me? Hello?
Yes, sir.
Okay, now say here. Suppose you have the two liquids,
Yes, sir.
liquid 1 and liquid 2, okay?
Yes, sir, I'm listening.
Okay, suppose you have two liquids and you have mixed
Okay,
into
sir.
that. So what will happen? Diffusion will occur, right? Diffusion will take place between the two liquids and the corresponding constituted particles will
Yes.
mix up with each other, causing the diffusion phenomena, okay? Right? Okay?
Okay, sir.
Now listen to me one
Yes,
thing.
sir.
Now listen one thing. Now the amount, now the speed or the rate at which the particle will start mixing with each other, that is called the rate of
Yes.
diffusion. That is what is it's called? Rate of diffusion. Rate of diffusion is actually the measure of the speed that the particles intermix with each other. Right? Now instead of taking the two liquids, suppose in the second cases I
Yes,
am
sir.
taking the two gases, suppose gas 1 and gas 2, okay? Now again we are doing the same thing, we are mixing these two
Okay, sir.
things. So when we are mixing that, we have mixed these two things, then again diffusion will take place. Okay, now what is the only difference between these two diffusion? In which case diffusion will
Okay,
take fast? That is, we are actually comparing the rate of diffusion in these two cases. One, when the two liquids are
yeah.
mixed, and when the two gases are mixed. In what case the diffusion will take fast?
Gas is faster.
Yes, it means the rate of
Gas.
diffusion, the rate of diffusion will be faster in the case of gas. Okay,
Okay, sir.
okay, the same thing is written here. There is the gaseous property diffusing very fast into other gases. Now see here, in the gaseous state what happens,
Okay, sir.
the particles moves about randomly at high speed, that is, the particles will possess the considerable amount of velocity, and hence it will possess the considerable kinetic energy, right? So due to this
Yes.
random movement, the particle hit with each other and the walls of the container, and hence exert the pressure on the wall, that I had already told you. Okay,
Okay. Okay, sir.
okay, now the next thing is effect of the change of temperature. Now suppose if you have any substance at any state, okay, now we will come to the
Okay, sir.
change of change of or the effect of change in temperature, we can say. In other word, we can say ultimately, obviously there will change in the state will occur, but the effect is due to the change in temperature. So we will see here effect of okay, effect of change in temperature. Are you listening to me? Are you listening to me or not? Hello, 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 can you hear me? Am I
Yes.
audible to you?
Yes, sir.
Okay,
Yes, sir. I'm listening.
okay,
Yes,
now,
sir.
okay, now see here. Now we are going to see what is the effect of change in temperature. Okay, although we know that the solid will have the definite shape and volume, okay, and
Okay, sir.
it has no compressibility, and it does not possess the property of flowing. Still, what will happen when we suppose start increasing its temperature? Okay, suppose it is anything which is in solid state, right? So we know that in case of solid, actually the intermolecular particles are very closely packed, and very strong intermolecular force acts between them, which keeps them in very tightly bound. But what will happen when we start increasing the temperature of the solid? Suppose, okay, suppose these are the particles, and we start increasing its temperature. Okay, it starts increasing temperature. Are you listening to me or not?
Okay, sir.
So actually what will happen when we start
Yes, sir.
giving the kinetic energy, like when we start giving the energy in the form of heat, so this energy will be transferred to the molecules, isn't it? So when the molecules will acquire the sufficient amount of energy
Yes,
to
sir.
overcome this intermolecular force. Actually, now listen to me. Actually, what is the force which keeps the two molecules bound together? That force is intermolecular, right? Okay,
Yes, sir.
that force is what? Intermolecular force. But suppose for the sake of convenience, we have considered
Intermolecular.
the two molecules only to make you explain in a better way. Suppose I am giving its energy in the form of heat. Okay, so when we start giving heat energy, so this heat energy will be transferred to the
Okay, sir.
molecules. So when these molecules will possess the sufficient energy to overcome this intermolecular force, so they will overcome the intermolecular force, and they will start moving. Okay, and their separation will increase slowly. So when their
Okay,
separation
okay,
will
sir.
increase, this process is called the melting. What this process is called? Melting, isn't it? Then what will happen?
Melting.
Then what will happen? Then this solid state will come into the liquid state, right? So what happens here? This means we have seen
Yes, sir.
here, when we change the temperature of any substance, then the change in states also occurs, right? Although this substance is found in the solid
Hmm.
state, but on increasing its temperature, it can be converted to the liquid state. This is called the change of state, isn't it? Now take one more
Okay, sir.
example. Take one more example.
Yes, sir.
Suppose, for example, you have an one of the iron block here. Iron block here. So we know that this is in solid state, right? But when we start giving its temperature, but
Yes,
when
sir.
we start giving the temperature to the iron, and so when the temperature will become very high amount of very high value, like the 1000 degrees Celsius, okay, 1000 and 2000 degrees Celsius. To 2000 and 1000 degrees Celsius is very high amount of heat
Hmm.
energy. When such energy is given to this iron block, so what will happen here? This iron will start melting,
Yes.
isn't it? Will it
Melt.
will it melt or not?
So,
Okay, it means
yes,
iron,
it will melt.
it will melt. So what happens? What we have observed from here, that whether the any substance is found in any state, whether solid, liquid, or gas, but when we change the temperature, when it changes temperature, then the change of state also takes place. Okay,
Okay.
and the now
Okay,
now
sir.
now listen to me. Suppose we have taken the example for this solid and you start giving the heat energy. So the amount of heat at which melting start, that point is called the melting point. That point will called as
Melting. Yes, sir.
melting point. Melting point is actually what? Actually, this
Melting
is the
point.
minimum heat energy required to melt any solid state into the liquid state is called the melting point. Okay,
Okay, sir.
fine.
Okay,
And
sir.
each element, each metal will have the different melting points. Some will have the low melting point, while some will have the high melting point. For example, recently we have discussed the gallium element. Okay, gallium, its melting point is very low, like 25 degrees
Yes.
Celsius. That is, it melts at the 25 degrees Celsius room temperature. Whereas in case of some other element that has a very high amount of that means that requires very high amount of heat energy to melt. Can you give me any example which has very high melting point, that is used in electrical appliances as well?
High melting point.
I am giving you a hint that is used in home appliances. That is used in,
Home.
yes.
Ice.
No. Now listen to me.
Ice.
What I am asking you. I am asking you, name the few metals which has high melting point and used in electrical home appliances. I am telling you. Okay. The first one is
Hmm.
what I have written here. Can you read it?
Tungsten.
Tungsten, right? Can you tell me where it is used?
Yes, sir.
Where it is used? This is used in electrical bulb.
Electrical.
Okay, electrical bulb as a filament.
Okay,
This
sir.
is also called filament. Okay. Okay. The next.
Filament. Yes, sir.
Now take the next example. Nichrome. Actually, nichrome is not the pure metal. Actually, this is the mixture of the more than two metals in some fixed composition, but it has very high melting point. And where it is used? It is used in heating appliance. In which?
Heating appliance.
Heating appliance. Can you give me some examples like heater? Okay, room heater. Okay, like geyser, right? So in these heating appliances, these wires are
Okay, sir.
used. Okay,
Okay, sir.
Okay, just a second. Okay.
Okay, sir.
Okay, now the point comes which I had told you already. Okay, read some points which I will tell you, and tomorrow we will discuss it in detail. What is written here? Can a matter
Okay, sir.
change its state?
Okay, sir.
So we have already seen that the obviously matter can change its state. What thing will you have to do to change the states of matter? What thing will you have to do for changing the state of matter? You have to increase the temperature. Okay, now listen to me.
Yes.
By what all ways can you change the states of matter? Tell me. By what ways?
Heating. Heating.
Yes. Can you change the states of matter? Can you change the
Heating.
states of matter? Only heating or something else? The first way is the first. Listen to me.
Heating.
Now listen to me. You have not answered
Um,
correctly. What have you said? You have said heating. Why? Why only heating? Why not cooling? Isn't it? Are you getting what I am saying? It is not right to say heating. Rather than you had to say
Yes.
changing the
Fusion.
change the temperature, like change in temperature. What factor?
Change of temperature.
Change of temperature means either increase the temperature or decrease the temperature. So both things can happen in the change in temperature. But when you say heating, so that would not be fine. Change in temperature. And what the second? Any other? By applying pressure. Okay.
Yes. Pressure. Okay, sir.
By applying pressure. So basically these are two basic methods to change the states of matter. So using these two ways we can change the states of matter. Now let me give you the one example for change in pressure. Suppose you have any gas, anything which is in gaseous state. Okay, when you apply the pressure on its wall, okay, so on applying this pressure, this gaseous state will come to the liquid state, right? Okay, so it was all about for today, and tomorrow we will discuss more. Okay, now tell me one more thing for the tomorrow schedule. Tomorrow is obviously Sunday, so there would be holiday in your school.
Yes, sir.
Okay, so it means tomorrow we can have the classes in like afternoon and the extra classes
No,
2 hours.
sir.
Yes. Do you have any other schedule? Hello.
So I have one class tomorrow.
You have on what time?
Yes, sir. Can you hear me?
Yes, yes. Yes, I can hear you. Tell me.
I have from
Okay, tell me your time.
6 to 7 my time.
6 to 7 p.m. you have
So for me 6 to 7 I have class.
PM or AM?
Yes.
PM.
PM.
It means in evening shift, right?
Yes, sir.
But we will be having the class in the afternoon
Evening.
schedule.
Yes, sir.
I'm saying that we will be having class in afternoon schedule, like 12 to 2 or 11 to 1 or 2 to 4, like this.
Yeah,
Any one of.
Yeah.
Okay, now listen to me. Tomorrow we will be having class
sir.
either from 2 p.m. to 12 to 2 or 11 to 1 or either 2 to 4, something like that. So there would be no any problem.
Yes, sir.
Okay, that would be fine. That would be fine.
Yes, sir.
Or is there any issue? Tell me.
Yes, sir. That would be fine.
Okay, okay. So final schedule I will send
No,
you.
sir. There's no issue.
Okay, okay. So finally, your timing. I will message you on WhatsApp. Finally, okay.
The time.
Yes. Are you saying something?
Okay, sir. Okay, sir. Yes.
Are you saying something?
Yes, sir. Okay.
Okay, so what I am saying, listen to me.
No, sir. I'm saying okay.
Okay, now listen to me what I am saying to you. I am saying you that final timing schedule tomorrow I will WhatsApp you. Okay.
Okay, sir.
Have you listened to me or not?
Okay, sir.
Have you got what I am saying you?
Yes, sir.
Okay, fine. Then we will see to on
Yes, sir.
tomorrow. We'll see on tomorrow. Okay. Okay. Shall I disconnect now?
Okay, sir.
Okay. Bye.
Yes, sir.
Okay. Shall I disconnect now?
Bye.
Okay. Bye.